What's up, everybody? Welcome back. I hope you're doing well. Today, we're talking about colligative properties. Now, today's lab is a little fun lab where we're going to be using only salt, water, and ice. But I'll show you that you can do a lot of cool experiments with just this setup. And before we get started, let's talk a little bit about colligative properties. What are colligative properties? Now, we talk about colligative properties when we talk about concentration. So, these are properties that when you increase concentration, these properties change regardless of what chemical you have um, in that beaker, right? Meaning that if you have water by itself, it might be able to boil at 100 degrees, for example. If you add salt into the water, guess what happens? Water is not going to boil at 100 degrees anymore. It's going to boil at like 110 or something like that, depending on how much salt you put in it. That is a property that depends on concentration. You increase the concentration, the the property changes. That is a colligative property. And where it comes from the number of particles, right? The number of particles. So here, I define colligative properties as properties that depend on the number of the solute particles, right? As you add more particles, these things change. There are four colligative properties. The first one is vapor pressure lowering, meaning that if you increase the if you increase the concentration, if you increase the number of things dissolved in a solution, it will lower its vapor pressure. The second is boiling point elevation. That's the one that I was just talking about. You increase the concentration, the boiling point will go up. That's the elevation, right? Lowering, so vapor pressure goes down, boiling point goes up, and then you have freezing point depression. So the freezing point goes down, and then you have the osmotic pressure. Osmotic pressure goes up. You increase the temperature, osmotic pressure goes up. Not temperature, but concentration. When you increase the concentration, the osmotic pressure goes up. So you have four important colligative properties. And in the lecture, we have formulas for each of the four. So you can not only know that, for example, the boiling point changes, but we can measure by how much based on our concentration. It's really cool. Now, what we're going to do today is going to be freezing point depression. So we're going to work with one type of colligative property called freezing point depression. So we're going to be changing the freezing point of a chemical based on the things that we're going to dissolve into that chemical. It's really cool. So the freezing point depression, right, again, is the change in temperature, right? It's change in temperature of freezing, right? So usually water freezes at 0 degrees Celsius, but if we add things to water, it will go lower, right? So we're going to measure that, right? And again, it measures, it affects that by affecting the concentration. So how does it look like? It looks like this, right? This is the formula. The freezing temperature, or the change in freezing temperature is going to be equal to Kf, which is the constant. You know, every liquid is going to have a constant, plus M, which is the molarity, right? And also not plus, but times. But also most importantly, it's times I, right? We'll go ahead and write it down. I, which is the number of ions or the number of particles. It's very important to know. So again, delta TF, or the change in freezing point, is going to be equal to I, which is the number of ion, times M, which is the molarity, times Kf, which is a constant. Right? So I is the number of particles. M is molarity, which with big L, and then Kf is a constant. Right? Think for water is 1.68. 1.68? I don't remember. Look it up. But we are going to use this. And by the way, particles is important to know what particles are, because guess what? If we have NaCl, let's say we have NaCl in a solution, what's going to happen is that NaCl is not going to stay together, right? It's going to separate into what? Into Na plus and Cl minus. So guess what? These are two particles. So the I for NaCl will be 2. It's an important distinction to know. I for NaCl will be 2. The I for magnesium chloride, for example, right, will be 1 magnesium and 2 chlorine ions. So I will be 3 here. So it's the number of particles, the number of things that are dissolved. So this is the main equation that we're gonna need to know for this lab, for today's lab. Make sure that you know that, right? So what are we going to do in today's lab? In today's lab, it's actually going to be really cool. So we're going to add a container like this, right? We're going to have a container like this. We're going to have, let's see. So if you have 3 containers, uh, and these will be beakers most likely, and you're going to do one by one. It's not going to be like 3 separate, 3 containers next to each other. We're going to do the first one, then the second one, then the third one. But what we're going to do is we're going to add different salts, different salt concentration. So here we're going to add a little bit of salt. Here we're going to add way more salt, right? Like 2 times actually, right? 2 times the salt. And then here we're just going to add a bunch of salt, right? Like lots of salt. Right? So these will have different salt concentrations. And guess what? Based on this formula right here, based on this formula, the salt concentration, as you increase the concentration, the change in freezing point should increase. As you increase the concentration, the change in freezing point should increase. So here they said, I don't remember the exact amount. I think it might have been like 10 grams in each bag that I gave you, but it's going to be like, okay, let's just say 10 grams, right? And then 20 grams and then 30 grams, right? So if you have a different amount of salt in each beaker, then the freezing point is going to be different. How are we going to check the freezing point? It's actually really cool. We are going to add a tube in there. We're going to add a tube. So we're going to add a tube in here with pure water. We're going to add tube with pure water here, right? And the idea is, right, because we have different amount, right? We have a different amount of salt. So we have just a little bit of water here, right? We have different amounts of salt, right? And the idea is if you have a different amount of salt, then it's going to freeze at different temperatures, right? So we're going to measure, so we're going to have a thermometer where we're going to measure the temperature of the ice, right? And we're going to also measure the temperature of the water, right? Again, we're not going to have a lot of thermometers, guys. We're going to have just one. We're going to have one thermometer where we're going to measure. And you're going to measure the temperature of the ice before and after, but then you're going to measure the temperature of the water as it cools down, right? So the hope is that maybe, the water is going to freeze at 0 degrees Celsius here. Maybe it freezes here at, I don't know, -5 degrees Celsius, and then here -10 degrees Celsius, right? I'm just making up the data, but you will see what your data is, because guess what? At room temperature with just ice, this water is not going to freeze. But I promise you that if you put this water, just plain water with nothing in it, with ice, and then you add ice water, and then you add salt to it, it's going to freeze. The water, you will see the water freeze in a beaker. It's going to be really cool. Hopefully it's gonna work out. But when it does, you're going to have different temperatures here, right? So if we look at your data sheet should have, like, you give me your, oh, it's actually way more salt than I thought. It's 30 grams and then 60 grams, right? So you're going to give me the temperature of the ice before. So the temperature of this beaker here, going to give me the temperature of the beaker before and after, right? And then here, you're going to measure the temperature inside the little beaker, the little test tube, over time. So from 0 to 30 seconds. So every 30 seconds, you're going to record the temperature. And then you're going to tell me, did the water freeze? And then you will give me the temperature at which the water froze, right? So you're going to have, for each one of these, you're going to have these, and the major things that we're looking for, again, is the freezing temperature for these, and then we're going to look at the differences in freezing temperature. And what I just seen, which is pretty cool, is this is 0 grams. So the first one doesn't have any salt, right? But we also, if it doesn't freeze, that's okay. You can use 0 degrees Celsius as the starting point, the freezing point with no salt, right? So that if it freezes here or here, then you'll be able to find the delta TF. What is the delta TF? Again, the delta TF, the change in temperature, the change in freezing temperature, right? Delta TF, right, is equal to I times M times, what's the, it's K, right? KF, right? Times KF, which is the constant, right? So in your data, you're going to calculate this, right? And delta TF really is going to be, right, the temperature, the freezing temperature when you added salt. So the freezing temperature at like 6 grams of salt minus the initial freezing temperature of water, right? And the initial freezing temperature of water is 0. And then maybe the new freezing point might be, I don't know, -5 degrees Celsius. So the new delta TF will be -5 degrees Celsius, right? So that's delta TF, right? Delta TF. So you're going to give me delta TF, right? So again, delta TF is freezing point of pure solvent for freezing point of the solution. Oh, actually, that makes sense. That makes sense. It's the other way around. That way we don't have zeros. Actually makes sense because it's depression. So 0 minus -5, right? 0 minus -5, which is +5. That makes more sense, right? So delta TF should be positive. Your delta TF should be positive. So again, your data is going to give you delta TF. All of this should give us delta TF. But we can also do some other fun stuff with this. Or you can like plot this, right? Over time, you can like, if you have Excel, you can plot this over time and see how the temperature goes down way quicker when you added salt compared to zero salt and all that stuff. So, if we have Excel, we might get a chance to do all of that. But after you get delta TF, you can measure, and I want you to do this. I want you to be able to measure the molecular weight. The molecular weight, that will be our major calculation in this lab. And I want everybody to follow me so that you can be able to do this, right? So look at this. Delta TF, right? And delta TF is equal to I times M times KF, right? And again, we already agree that you can find, so you can find I, because for NaCl, for example, is 2. Delta TF is our experimental data, and then KF is a constant, right? For water, I think it's either 0.68 or 1.52, right? I'm going to give you the constant. And that means that you can find the molarity. So you can find the molarity from here, because then M, right? M, if you move this around, will be equal to delta TF over I times what? Times KF, right? So we can find the molality from here. Now, if you have the molarity, so this is the first equation, that will be the second equation. But we know also that the molarity is equal to N, which is moles, right? Over what? Over kilograms of solvent, right? This is the molarity. Okay, so you already found the molarity here, and we know that the molarity is equal, the molality is equal to moles over kilograms of solvent. And guess what? From your experiment, from your beaker, you have your kilogram of solvent, right? If you don't have the kilograms of solvent, you can just convert it very easily because it's water. Yeah, we have some ice in it, but we can approximate. The beauty with water is that the density of water is 1 to 1. So if you have 1 liter of water, you have 1 kilogram. And then if you have like 100 milliliters of water, then you have 100 grams of water. If you have 250 milliliters of water, you have 250 grams. So you should be able to, from the beaker, find the kilograms of solvent. So here again, let me just say that, okay, we calculated M from here. We got kilograms of solvent from our experiment, which means that we can find the moles, right? We can find the moles from here. How would we find the moles? Now again, moles here, and the moles of what we have will be equal to molarity times kilograms of solvent, right? That will give you the moles of what we have in the solution, right? The moles of what we have in the solution. Now, if we have the moles of what we have in the solution, guess what else we know? So that will be the next equation. Another thing that we know is that moles, right? Moles is equal to mass in grams over the molecular weight, right? Mass in grams over molecular weight. Why is this important? It's because guess what? We have the moles from here. We have the mass from our experiment. We're trying to use the salt, right? So the salt here from our experiment, I think I did say see 30 grams here and 60 grams. So depending on what temperature you ended up choosing here, if you chose here, the mass will be 60 grams, right? So you have the mass from your experiment, right? So you can just go ahead and be like, okay, I have the mass from my experiment. I have the moles from here. Guess what we can find? We can find the molecular weight. We can find the molecular weight. So the molecular weight, right, in here, the molecular weight, if you move this around, the molecular weight will be equal to mass in grams over the moles, right? And that is the equation, guys. That is the equation. So if I gave you an unknown compound dissolved in water, just by learning how it changes the freezing point, we can back calculate its molecular weight. And if you have the molecular weight, you can find its identity. See what I mean? So that is the calculations. Those are the calculations that we need to know how to do for this lab. After you have measured the freezing of these of our little test tube, the freezing of our little test tube in three different conditions, right? And the way you're going to do it, guys, is you're going to start with a beaker with ice and no salt, and then you're going to add your test tube, and then after that you're going to um, add 30 grams of salt, and then you do the same thing, and then you're going to add 60 grams of salt and you do the same thing. Remember, you're going to measure the before and after temperature of the ice each time, and then in between you're going to be measuring the temperature of the inside of the water inside the test tube, and then at the end you will see did it freeze or not, and then if it's frozen you're going to give me the freezing temperature. That is what we're going to do. That is what we're going to do. And it should be a really fun lab about colligative properties. And hopefully, you're going to see the freezing. You should be able to see the freezing if you add the salt correctly. And then if you don't use too much water, you should be able to see it. But other than that, let's get started with the experiment. You should have everything that you need. So let's begin. This lab is going to be very simple. And for this, you're going to need just a few things. So you're going to have a beaker. You're going to have about 3 test tubes. You're going to have a thermometer. That's important. You're going to have a test tube rack or test tube holder. You're going to have pure water, not sink water. You're going to have pure water. And then you're going to have salt. So you should have like 3 bags of salt that have, I think, 20, 30 grams each. And then, more importantly, you're going to have to supply ice. So you're going to need a little bit of ice. If you don't have ice, make sure that you stop this and then go find ice to begin with. We also have a thermometer. You should have a thermometer with your kit, but if you're not, make sure that you can find it or find a way to measure the temperature. So, as we discussed in the introduction, we are going to measure what changes with the freezing point, or how water freezes, or the temperature at which it freezes when you add something to the solution. In this case, we're going to use salt. Very simple. So in our setup, we're going to have, and again, in addition to what we need, we definitely going to need gloves and goggles as always, right? Always need gloves and goggles no matter what. Okay, so we're gonna get started with gloves and goggles, right? Making sure that we have everything we need, and then we're just going to get started. All right, so to get started, put on your gloves, put on your goggles, and start putting things into your solution. So after making putting on your protection, and then you're going to put you this is a table that we're going to use, and I am going to get back to this table, but before that, we're going to start with putting water, pure water, 1 milliliter of pure water, DD2O, into 3 tubes. Right, start by putting 1 ml of pure water into 3 tubes, and you can measure the 1 ml using your pipette, or you can just add about 25 drops, as long as you have the same volume of 1 ml into all of the tubes. You should be good. So after you filled all the tubes, you're then going to put your ice into the beaker. So we're just gonna go put some ice into the beaker. And then make sure that you have everything to go. Make sure that you have your thermometer. Make sure that you have your ice. You can add a little bit of water into the ice to make it ice water, so that your tube will be able to fit, but make sure that you add the same amount of water in all experiments, just a tiny bit. But before you get started, let's go back to the table so that you can understand what we're doing today. So we're going to do 3 experiments, right? And we're going to put it into this table, right? The first experiment is the one where you don't have any salt in it. We're going to measure the temperature of the ice before, and then you're going to measure the temperature of the ice after, right? So the first thing that you're going to do before you measure the temperature of the tube, you're going to measure the temperature of the ice, right? Very important to remember. And then after that, you're going to clean your thermometer, then you put it into your little tube inside the ice, right? I want everybody to get that, because if we don't do it like that, we're going to lose our data. So you're going to, again, after you've added all your water, we're going to measure, again, you're going to do 2 measurements, right? One in the ice before and after, and then after you measure, you're going to measure the temperature inside the tube. And the temperature inside the tube will be the temperature before you add. So the first will be the temperature before you put it into ice, right? That will be at time 0. So we're going to measure the temperature at certain time. So time 0 will be the temperature before we add ice, before we put it into ice. And then you're going to dump it into ice, start your timer, and then you're just going to record the temperature every 30 seconds until 5 minutes, right? So every 30 seconds, every 5 minutes, you're going to be measuring the temperature. So you can leave the thermometer inside and just look at your timer. You can use your phone as well, but as you can see in the video, Bryson is just recording the temperature every 30 seconds. So make sure that you have your timer or your phone. Every 30 seconds, write down the temperature, wait, write down the temperature, wait, write down the temperature, right? So this is what you writing down, right? However, sometimes it might freeze, right? So we want the water inside the little tube to eventually freeze. So it might not freeze in the first one, but again, at the bottom of the table, you see, I'm asking you, did the water freeze? Yes. If we say yes, give me the temperature and time at which it froze, right? If the water froze, give the temperature and time at which it froze. So you gotta be keeping an eye on it to make sure that it doesn't freeze, or make sure that it freezes, right? So the idea is that it's going to look different. It's going to be different. So if it doesn't freeze, go all the way to 5 minutes, right? Which is, 30 seconds, 30 seconds, every 30 seconds, all the way to 300 seconds, right? To 300 seconds. 300 seconds should be 5 minutes, right? So you're going to do this again. It's a 5 minute experiment after you've set it up, and then you're going to go to the next part. The next part is the same thing, right? Same amount of ice. So you're going to add the roughly the same amount of ice, then you add water. So you're going to do it in the same beaker. Dump the beaker and then go to the next add ice, right? Oh, before you do that, very important, remember to write down the temperature of the ice after, right? So we wrote the temperature of the ice before, write down the temperature of the ice after, and then after that you go to the next part, right, where you not only use ice but we add salt into the ice. And if you remember correctly from our experiment, this should affect the freezing point, right? The freezing point of the ice, the freezing point of water, the freezing point of and the temperature and the cooling down of the water inside inside the little tube. So after you add the bag of water, you're going to measure the temperature before, and then you're going to measure the temperature in the tube before, and then you're going to put it in, and then you're going to keep recording over time until it either freezes or we get to 5 minutes, right? So keep an eye on it to make sure, because it might freeze. You might not believe me, but it can freeze. It might not freeze in pure ice, but it will freeze in ice that has salt in it, right? So you go into, again, record the data into, guess what? This table, right? So the second one is 30 grams of salt. You measure the ice temperature before, ice temperature after. Then you measure the temperature inside the tube over time. Check whether or not the water has frozen. And then if it froze, write down the temperature at which it froze, the temperature and time at which it froze, and then stop, right? After it freezes, stop. You don't have to go all the way to 5 minutes. And then again, write down the the temperature after, right? And then after you're done with that, guess what you do it in the third time, right? And you notice that we're using the three tubes at three different concentration. And in the third time, guys, very important, do not throw away your ice at this point. You're just going to add in the 30 gram of ice you've already added, you're going to add another bag to make it 60 grams. Right now you have 60 grams of salt, so you have even more salt. So you're going to do the same thing where you're going to have temperature in 60 grams of salt, temperature before, temperature after, temperature inside the tube over time. Did it freeze at what time or temperature? Did it freeze at? And then hopefully, if you do it correctly, you see a big difference between 0 milligram of salt, 0 grams of salt versus 30 grams of salt and then 60 grams of salt. You should see a huge difference in how fast the temperature goes down, whether or not it freezes, the time and temperature at which it freezes. Right, that's an important part of our experiment, right? And I hope everybody understands that, because after you've done that, guys, hey, you are done with your experiment. You're done with your lab. But again, you're done with the experimental part, but you absolutely need to analyze this data. You have to analyze this data in order to understand, right? You understand, hey, what was the effect of adding salt? What was the freezing temperature? We call it the freezing point. And how much did the freezing point change once we've added salt? Did the change become more drastic when we added more salt? You can even graph this, time versus temperature, so that you can see that the temperature goes down slower or faster depending on whether or not we added water. Then guess what? The change in freezing point. If you froze in at 30 grams and then it froze at 60 grams, the change in freezing point times the molarity, right, can give you the KF, what we call the KF, or the freezing constant, right? So these are the calculations that you're going to do after you perform your lab. And very important, just like in all the other labs, you're going to have to clean up, right? So after you've done, make sure that you clean up your experiment, clean up after yourself. This one is easy because again, you're just going to get rid of the ice, get rid of the salt, clean up the test tube, and then you should be good to go. All right, that was colligative properties. I hope you enjoyed it. Make sure that you give me all the data, all the pre-labs, post-labs, and as usual, if you have any questions, feel free to reach out. And other than that, I will see you in the next one. Bye bye.